So in this experiment, it is clear that in the beginning, the zinc plate is negatively charged. So the electroscope also negatively charged, and the gold foil, they are separated, they are diverged. And if we allow the ultraviolet light to fall on the zinc plate, what is happening? The electrons are ejected. The electrons are ejected by the ultraviolet light. So what is happening? The number of electrons on the zinc plate is decreased, and the number of electrons in the electroplate also decreased. So when the number of electrons in the gold leaf is decreased, the gold leaf come close. So this shows what? With the help of ultraviolet light, we can eject the electrons from the zinc plate. Why it is not happening with the visible light? I already explained that visible light energy is less than the energy of the ultraviolet light. So here in this experiment, we are ejecting the electrons with the help of light, and this phenomenon is known as photoelectric effect. So what is photoelectric effect? It is the ejection of electrons from a metal surface when light of suitable frequency incident on it. So photoelectric effect means it is the ejection of electrons from the metal surface when light of suitable frequency incident on it. From one metal to another, we need different types of energy. That means we need different radiations to get the photoelectric effect. For zinc plate, it will happen with the help of ultraviolet light only. So from one metal to another, photoelectric effect takes place with the different radiations. So photoelectric effect means it is the ejection of electrons from the metal surface when light of suitable frequency incident on it. For alkali metals like sodium, visible light is enough for the photoelectric effect. Why it is so? You know that in alkali metals, in the outermost orbit, only one electron is there. So the alkali metals are ready to remove the electrons with less energy. So visible light can provide that energy, and for alkali metals, only visible light is enough for removing the electrons. So for alkali metals, photoelectric effect takes place with the help of visible light. But for zinc and platinum, photoelectric effect takes place only with the help of ultraviolet light, because ultraviolet light can provide more energy than visible light. So zinc and platinum, they need more energy for removing the electrons, and the photoelectric effect can takes place. So from one metal to another, photoelectric effect takes place with different radiations. So there should be a minimum frequency or minimum energy for the photoelectric effect. So the minimum frequency is required for the photoelectric effect is known as cutoff frequency or threshold frequency. So threshold frequency or cutoff frequency means it is the minimum amount of frequency required for the photoelectric effect. So with the sodium metal, that frequency can provided by the visible light. For zinc and platinum, that frequency can be provided by the ultraviolet light. So from one metal to another, threshold frequency is different or cutoff frequency is different. So threshold frequency is what? It is the minimum amount of frequency required for the ejection of electrons from the metal surface, or it is the minimum frequency required for the photoelectric effect.